Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about perpendicular bisectors of triangles. And this is section 5.2 in your geometry books. So let's start here with a segment. We have segment AB in front of us. And if we want to know what a bisector is, a segment bisector is a ray, line, or segment that cuts a segment in half. It can also be a ray, line, or segment that intersects a segment at its midpoint. Okay? And then if we want to know what perpendicular means, it means that a figure is intersecting another figure at a 90-degree angle. Okay, so the 90-degree angle here is what to focus on. And therefore, I guess, as a perpendicular bisector, it has to be both a bisector, so cutting the segment in half, and then cutting it at a 90-degree angle. So let's take a look at the diagram here. Let's draw a perpendicular bisector of AB. So let's start with this segment here. And we'll call this W. We'll call the top point W, and we'll call the bottom segment X, or bottom point X. And here, the notation to indicate that this is a perpendicular bisector, first of all, it has to be, you have to have congruent marks here and here to indicate that the segment is cut in half. And you also have to have a box, which means a 90-degree angle, so making the segment WX a perpendicular line. Now let's call that point in the middle where the two lines intersect, or the segments intersect, point M. So here, point M is the midpoint of segment AB, and WX is a perpendicular bisector of the segment AB. Now, if I were to take away some of the information here, say if I were to put in the fact that this is congruent to this, but let's say that I don't indicate that it has a box there, so that there's no 90-degree angle, then we cannot assume that this is a perpendicular bisector. Even though it may look like it, we cannot assume it, because we don't know really if this is cutting at this kind of angle here. I mean, it could still be cutting through the midpoint and be a bisector. So in this case, WX is still a bisector, but it's obviously not perpendicular. Okay. What is also interesting, and make sure you have this notation correct, is that if you just have a 90-degree angle symbol right here as the box, okay, that also does not necessarily mean that this is WX is a perpendicular bisector, because I can move this segment here along the segment AB, and we can obviously see now that it's not a bisector at all. It's not cutting the segment AB in half, and so it can be perpendicular without ever being a perpendicular bisector. So let's go ahead and put that back as a perpendicular bisector, and this was our original drawing. Okay, so now we know that WX is a perpendicular bisector. And what we can say about perpendicular bisectors is this. Any point that is on the line here, see, notice how there's a point that's going to be dragged. Any point along this segment, WX, is going to be equidistant from the two endpoints AB. So for example, if I took this point here, let's go ahead and start with a point here, and I said, what's the distance between this point to this point and from here to here? Well, that distance would actually be equidistant. It'd be the same. So let me go ahead and draw that. We have the distance from there to there. We have the distance from there to there. And let's call this point, let's call this point up here point K. So what we can say now is that point K is equidistant from the endpoints AB. Or in other words, segment AK is congruent to segment KB. So So we can draw little dash marks in here to indicate that these are congruent. So 2 dash marks, and let's go with 2 dash marks. Okay. Now again, I can move this point K along this line, and wherever I move it to, it's going to be equidistant from the points AB. I can even move it down here, so no matter where I put this point K along the perpendicular bisector, it will be equidistant from the 2 endpoints. Okay? Now, we can also draw another type of figure. So let's do this. Not real sure why it's not letting me. There it goes. Okay. Now let's say we didn't have this segment in here any longer. And let's get rid of all the other extra letters and things. Let's just say we had a point out in space. Let's say we had a point right here out in space. And we'll go ahead and call that point K. And we want to know, is this point going to be on the perpendicular bisector of AB? Well, if I knew this information, if I knew that the point K was equidistant from K to B as it is from K to A, if I knew that those two distances were the same, then I could say, yes, this point K would be on the perpendicular bisector of AB. So let me show you what that looks like. We have having some technical difficulties here. Okay. So let's say we had the 2 congruent marks to say these 2 segments are congruent. Then what we could say is that point K actually lies on the perpendicular bisector. So if I were to draw a perpendicular bisector through the segment AB, well, guess what? Point K would be on there. Point K would definitely be on there. And then obviously we'd have to have the notation to indicate that this segment here is a perpendicular bisector, which would be the 90-degree angle and the 2 segment marks. Okay? But let's say I take that away, and I take that away. And let's say I take this away. And let's say that I just have point K out here in space. Then I would not be able to say that K is on the perpendicular bisector here because there are no congruent marks. Or in other words, I don't know exactly where K is at. You know, obviously, if I were to draw that perpendicular bisector again, we can see that point K would not be on it. And again, since we don't have those congruent marks on KB and AK, then we can't say that K is going to be on that perpendicular bisector. This will conclude our lesson for perpendicular bisectors of, oh, I'm sorry, no. We have perpendicular bisectors of triangles. So let's say I draw a triangle here. And let's call this point K again. And we'll call this point A. And we'll call this point B. Okay. So if I were to draw a perpendicular bisector of the triangle, I would first start by finding the midpoint of each segment. So here is a midpoint, here is a midpoint, and here is a midpoint. The way we indicate that those are midpoints is by creating the dash marks to indicate that the two segments are congruent. So here, this is congruent to this is congruent to this, and this is congruent to this. Okay, so all those are midpoints. Now we can go ahead and name those points if we like. We can name one of them W, one of them M, and let's name the other one X. Okay. Now if I were to draw the perpendicular bisector of this bottom part of the triangle here, so segment AB, if I were to draw that perpendicular bisector, it would have to look like this. It goes through the midpoint. So it goes through the midpoint. And not only that, but it intersects at a 90-degree angle. So I'd have to have a 90-degree angle mark here in order for this to be a perpendicular bisector. Okay, and then if I were to draw a perpendicular bisector through this, I would draw here. So here's a perpendicular bisector. And we need to indicate that it's perpendicular here. And let's draw the last one. So we have this segment going on. And let's go ahead and put that straight through there. So these are not exact diagrams here. Let's go ahead and fix it a little bit. And we can notice that all three of the perpendicular bisectors of the triangle are intersecting at the same point. So the segment RW, the segment RX, and the segment RM are all intersecting at this point here. And what is significant about that point R right in the middle here is that point R is equidistant from the vertices of the triangle. So let's do this. Let's put a point at R. So there's where the three perpendicular bisectors met. Is that going to stay? Nope, it's not going to stay. Okay. So here again, the point R is, again, where all the perpendicular bisectors meet. The point R is equidistant from A to R, from B to R, and from K to R in this case. So this concludes our lesson on perpendicular bisectors of triangles.